So welcome to our webinar on infrared electrical inspections. We're going to be talking about what they are, how it helps, and why it's required, and what the requirements actually say about them. So thinking about electrical infrared inspections, IR scans or thermography, it's getting a lot of traction. I think a lot of people have a general idea of what it is nowadays, but maybe not the specifics, or maybe not quite understanding why it's so important. So I'm going to hopefully answer those questions today. Again, if you have any questions or feedback or comments or stories or whatever, if you want to interact with the webinar today, interact with me today, please find that question feature or that chat box, and I will be monitoring it throughout the session. But let's just dive right in here. So why do we care about electrical risk and infrared scans, for example? Well, OSHA does require that electrical equipment be free from recognized hazards that are likely to cause death or serious physical harm to employees. Okay, so what does that mean, free from recognized hazards? Well, there's three main hazards that we're worried about for those who work on or near electrical equipment. Main ones. There's other ones as well, like electrical fire. That's not specifically listed here. I'll talk about that a little bit more later. But the main ones are electric shock, arc flash, and arc blast. Now, electric shock, if there's any chance of exposure of being shocked for 50 volts or greater, that is considered serious, it's hazardous, and needs to be addressed appropriately. The arc flash and arc blast sides of things are a little more complex. I can't just give you a voltage or an amperage rating and tell you this is how you protect yourself. Unlike shock, which really is mostly the voltage, and then you can figure things out from there. Arc flash does require a full study to know what it is going to be as far as hazard levels concerned. What I'm more going to be focusing on today is how infrared can help prevent these incidents from happening, from these electrical hazards hurting people in your workplace. We've done plenty of webinars and have plenty of content on our YouTube channel currently about what these hazards are, and more about in-depth protecting from them. So I don't want to spend too long in our short session today talking about these hazards, but it is important to recognize that everything we do, compliance and safety standards wise, is to address things that could hurt or kill people. We're not just pulling this out of thin air. There are reasons, there are stories, there are incidents, real life examples that prove how important these can be as far as life and death stuff is concerned. So yes, electric shock, arc flash, arc blast, very important hazards to understand. If you need more information, I recommend going to our website or our YouTube channel and looking into more resources there. But how does that relate to our topic today? Whenever it comes to electrical safety in the workplace, you have to have an electrical safety program. Again, we have a whole other topic on that, so I won't spend too long, but a big pivotal point in that are electrical risk assessments. Okay, so you can't necessarily document step-by-step procedures for everything you face in the workplace, but you can get pretty close. Once you get into the troubleshooting mode, for example, though, it's kind of up to the qualified person to make some judgment calls. So there's several levels that you can do a risk assessment procedure with, but throughout the process, you need to be able to identify those hazards. What are the hazard levels to begin with? Okay, so that comes from understanding equipment labels like voltage markings and arc flash labels and things like that. It helps you identify what hazards are even present to begin with. Great. But then we have to assess the risk. And by that, I mean looking at the likelihood that something could go wrong and the severity if it did. Okay, so risk is two factors there, likelihood and severity. Now, the likelihood could be dependent on things like, well, what are people doing? What kind of work is being performed? That makes a big difference. Also, who's doing the work? Are they qualified or not? You got to make sure you have qualified people doing it. A big factor in that likelihood and severity, though, assessing your risk, is condition of the equipment. What are you working on, and why are you working on it? Is it routine maintenance, or are you having to get in there because something is potentially causing problems? Okay, so that's a big portion of it, and that can be very nuanced to figure out unless you have procedures or inspections or studies performed, analysis performed to help you give workers the tools to assess the risk effectively. Take out a little bit of that nuance, a little bit of that gray area by giving them data to assess the risk more effectively. Okay, so that's where this infrared survey process fits in your risk assessment procedures. Then you have to be able to implement the right risk control methods. Okay, so I think I'll circle back on this a little bit later whenever we talk about the results of an infrared survey, because anybody nowadays thinks, oh, well, I can just go get a camera and I'll point and shoot and see where the hot spots are. But there's a lot more to it than that. And what to do when you do find a legitimate quote unquote hotspot may be pretty straightforward. It may not. So you have to really think about this. I feel like I'm setting this up a lot, but risk assessments are such a big piece of electrical safety, and infrared electrical inspections help you, like I said, identify what pieces of equipment could have problems. And I've talked about it nuanced, but we're going to dive in here in just a second. So, like I said, a major factor of your risk assessments is the equipment. What is the condition of that equipment? That's why it's so important to have an inspection process, especially for newly installed or modified equipment, so that whenever you turn it on, it's not going to be a problem right away. Great. But in general, you also need to think about the condition of maintenance. When was the last time it was opened or lubricated or serviced? Is it in an environment that could have degraded? What does that look like? How can you tell if it's degrading or if it's becoming defective? And if it is defective, even opening it can be hazardous. So performing the maintenance task suddenly becomes a higher risk if it hasn't been maintained properly in the past. It's like a cycle, and you got to figure out where to start. Where are you at? So the age and general condition of the equipment is a big factor in determining your electrical risk. This is where the NFPA 70B comes in. It's the standard for electrical equipment maintenance, and following this can drastically reduce your risk, because these questions will be answered in a simple and confident way if you've had a maintenance plan established that follows the 70B. Another good standard to look at would be the ANSI NETA MTS, or the maintenance testing specifications. It mirrors a lot as far as what NFPA says versus what the NETA standard says. A lot of it mirrors as far as what needs to be inspected and how often and things like that. But we're looking more into the NFPA 70B today. Okay, so for those of you who aren't really familiar, it is the standard for electrical equipment maintenance, and it was released in 2023 as a standard. It had been around for many, many, many years before that, but it was called recommended practice, and so people didn't really pay attention to it. Now all the you should do this turned into you shall do this, because it's now a standard. So the purpose is to provide practical safeguarding of persons, property, and processes from the risk associated with failure, breakdown, or malfunction, and a means to establish a condition of maintenance of electrical equipment and systems for safety and reliability. That's a lot. Okay, so that's the purpose from their book, copy paste right there. Failure, equipment failure, breakdown, or malfunction can absolutely cause people to get hurt or killed, depending on what it is and how it fails. So being able to identify that ahead of time and establish a condition of maintenance, saying, okay, where is this? How is it currently? What condition is it in? Can help you determine your level of risk. So the 70B gives you the tools and methods to establish that baseline and then figure out how to lower that risk. One thing to note, the NFPA 70B is not meant to duplicate or supersede manufacturer's instructions. So if you have a maintenance plan already based on the manufacturer's requirements, this can help fill in any potential gaps, but you're certainly not starting from scratch. You know, this is supposed to be used in conjunction with your manufacturer requirements for each specific piece of equipment. The problem is there's a lot of manufacturers that focus on the mechanical and moving parts and other things that are a little more physically understood. And electricity is kind of this nuanced magical world that not a lot of people get into unless they're specialized in it. And so their maintenance requirements don't really address the electrical components of their systems either. So then the 70B in that case can be what you look to fill in those gaps. Okay, but don't be using this just by itself. Always reference the manufacturer's requirements as well. This does apply to pretty much all the same industries we talk about for the general industry and OSHA and the NFPA 70E and the National Electrical Code. So maintenance for electrical, electronic, and communication systems and equipment, for industrial plants, institutional and commercial buildings, large multifamily residential complexes. Again, vast majority of industries can be underneath the NFPA and specifically the 70B umbrella. Okay, so when it comes to what it has to say for electrical infrared inspections, we look to Chapter 7. And if you don't know a lot about the NFPA 70B, or you need a little more information about what it is, what it entails, we have a whole webinar about that. We published it right after the 70B became a standard, so it gives a good breakdown there. But we're just going to jump to chapter 7 because that's what's specific to this topic today. Okay, so infrared thermography. It is supposed to tell you where there's a difference in temperature. Okay, so if there's something that's supposed to have a similar load in a similar environment and the ambient air temperatures are the same, well, then their temperature should be very similar as well. If they're not, that could be an indication that something is wrong, that it's not actually operating the way it was supposed to be or designed to be. Now, there's other considerations. You know, if you're comparing two breakers in the same panel, but one of them has, you know, a couple outlets and the other breaker has a whole bunch of stuff running off of it, it has more load, it has more demand, it will potentially run hotter, right? So we have to think about similar electrical loads as well. Okay, so all accessible and necessary covers shall be removed prior to infrared thermography inspection to provide a clear line of sight to the equipment being scanned. In other words, taking a scan on the outside cover doesn't really do you much good. Okay, you have to be able to actually see the electrical components, not just the case that holds them. Okay, so where you can. Temperature differences need to be documented. So thinking about reports or finding some way to circle back and reference that information later would be very important. They need to be performed at normal circuit loading. In other words, don't schedule it for your shutdown week where nothing's running because you're doing all the other maintenance stuff as well. Hey, yeah, we'll just do infrared during the same time. No, that doesn't give you a solid look at what the loads are actually like and how what the normal temperatures you should be seeing are going to be present. So if that's not feasible for some reason, let's say you're in an explosive environment, hazardous classification area, and so opening equipment to see the conductors while there's all this dust in the air is actually more hazardous. Okay, maybe you're not going to do that. That's where we look to the 7.4.5. If normal circuit loading is not feasible, circuit loading of not less than 40% can be permitted. In other words, you still want it running, but maybe it won't run the full load. Maybe you'll swap out or clean out the hazardous stuff and have it just running the motors. Maybe that's about 40% of the normal load, maybe a little higher depending on what it is that you're processing. There are ways around this. Okay, and then whatever loading characteristics you use do need to be documented for future reference. Okay, so that's what the 70B says about infrared thermography, which is all fine and great for those who know what it is. We're identifying those hotspots. Typically, you use an infrared camera, like example being the one that you see on the left, but there's a whole bunch of options out there nowadays. Whichever camera you have or have access to, make sure you know how to use it. And if you're not comfortable with all the features, this is a time where it would make more sense to hire it out to someone who has been trained and certified on how to use these cameras and what actually it's showing, so you don't end up in some of the pitfalls that I'll talk about in just a minute. Okay, so the idea of seeing the actual electrical components. So, you know, for example, that panel, yeah, the dead front's still on, but you can see the breakers, okay, and that'll give you an idea of what's going on, but don't take the infrared scan with the door shut. That doesn't make any sense. But even better if you can go ahead and open it up and see the connections themselves, like the one on the bottom there. One little note, these are stock images, not necessarily real life pictures. You should definitely be wearing your PPE if you're going to open up and expose that. There should be boundaries in place, all the wonderful things. I'm just going to assume the one on the bottom didn't have it on while they opened it up, because that'll make my heart a little bit happier as far as safety is concerned, but then it doesn't make the infrared scan very useful. So it does require someone qualified, because they're going to have to open it up and expose those conductors and circuit parts. So you have to know what the hazards are. You have to be able to address them appropriately with PPE and boundaries and whatnot before you can do an infrared inspection. Just a little side note there. Okay, so the purpose of these scans, as required by 70B and NETA, is to help detect and verify potential heating issues on your equipment. Okay, so motors, transformers, switchgear, switchboards, panel boards, disconnect switches, even control cabinets. We're going to want to see, well, are there hotspots? Sometimes just looking at it with the naked eye, you can tell something's wrong, right? If it's glowing red, for example, you don't need an infrared camera to see that there's something wrong, but a lot of times it's more subtle than that. It's more nuanced. And so you you do need an actual infrared camera to be able to see those hot spots. It'll pick up things that are not visible to us. Our eyes don't detect it that way. Okay, so an example here, the images that you see popped up came from an infrared inspection that we performed. So on the left, now that we're looking at it, we can kind of see there's some discoloration, but if you don't really think about it, maybe you thought that conductor was just dirty, not actually discolored from overheating. So knowing that kind of stuff ahead of time, what to look for, can help a lot, but until you get an infrared camera on it, how do you know what it is? What's actually the problem there? So a lot of people ask, well, how often do you need to do these scans? Well, we can go to chapter 9 in the 70B, maintenance intervals, and a lot of people want to have just a straight up answer, every year. Okay, vast majority of equipment, I would hope we can just do once a year. That's the minimum requirement, is annual. But it depends on the current condition of that equipment. So the maintenance frequency modifications in 9.2 need to be adjusted according to the different conditions. You can go and read through this or ask questions later if you'd like. I'm just going to jump to that table that's referenced. So the maintenance intervals, all electrical equipment need to have an infrared thermography performed, scan performed. For condition 1 and 2, it's the same every year. Condition 3 is every 6 months. So what do the different conditions mean? It's every year or every 6 months. So how do you determine what your equipment needs? Well, let's go back to those equipment modification or equipment condition assessment specifications. So condition 1 is like new equipment. You've kept up on its maintenance stuff. There's not been any problems. There's no moisture, nothing's been damaged, and that you've performed the maintenance required per the codes and standards and the manufacturer's requirements. That's condition 1. Okay, so every year you're good to go. Do your annual scan just to make sure that it's still in good shape. Condition 2 is that, hey, there might have been something wrong. It's had a maintenance result that deviated from past results, indicated that there's a potential problem that's beginning or has already happened, and we need to check on this a little more often. A lot of the other maintenance requirements increase the time frame, or I should say decrease the time frame. You're doing it more often for condition 2, but for infrared, they're like, yeah, well, still just do your annual thing. That's bare minimum, by the way. Condition 3, though, if you've missed the last 2 required maintenance cycles according to what's in the book and your manufacturer's requirements, it's already condition 3. So even if it hasn't caused a problem, but you have missed maintenance cycles, 2 consecutive maintenance cycles, which depending on what it is, could just be a few months of missing things or even 1 year, then it's every 6 months at that point. If there's some major issue, major replacement that you've had to do, there's unaddressed issues in the system, you're kind of running on the gotta put out, hopefully, metaphorical fires, you're probably looking at condition 3 equipment. So you need to do it every 6 months until you can get it down to a 2 or a 1 as far as its reliability. Okay, and we can go more into depth about that, but let's just move right along here. So understanding what condition it is, maybe it's hard to figure that out right off the bat. Having an infrared inspection can help you determine that. That's the cool thing about these. Yes, you have to do them every year just to make sure everything's still going, but if you don't really have a clear starting place for your maintenance plan as well, you can use an infrared inspection to help prioritize some things. Such as, if there's a critical deficiency, that there's a pretty serious hotspot that's been identified in your thermography report, well, then there's your first priority. There's where you get started, and then you can go back and check on them later. The little to no deficiency, the ones that are just running as normal, yes, still include them in your maintenance plan, but if you have to figure out a priority list, this is a good way to do it. Now, how does this help? How does this help? Well, if you have an infrared report, and you know that there's a bigger problem with a specific piece of equipment, you can address it before it causes equipment failure. You're already dancing that line. It is overheating, but what could that overheating lead to, or what does that point to? Well, it could be a loose connection. Eventually that could fall out of its connection, out of its lug, or whatever, in this case, the termination, and cross phases. It could hit the side of the disconnect and then just quote unquote randomly blow up on you, cause an arc flash. If it's a loose connection, that can absolutely happen. It could overheat to the point where it actually starts an electrical fire, depending on how and where it's installed. So yeah, having these infrared reports is a proactive way to identify and prevent electrical hazards. Okay, so that's the really cool thing about it. And then the other side is it just keeps things operational. It keeps things up and running, so you don't have unexpected downtime. You can identify that there's a problem and say, all right, we need to schedule this in the next couple days or today, and say, we'll make this work. We'll reallocate our resources. We'll shift around personnel or material. You know, if you're processing things, you've got lines of equipment that's processing a widget, for example, or some food. You can cycle that stuff off of that line so that you're able to fix this problem in your terms, on your timeline, rather than it shutting down the whole production area and now you're in a reactive mode. Okay, so that's the other side of this. Helps eliminate hazards by preventing them to begin with, and it helps eliminate unexpected downtime. Okay, so let's go through a little bit more about what you get from an infrared inspection. All right, so this is going to be from an example report that we did, and actually this was sent out just yesterday, a couple days ago. So it's very recent that you can look at. We'll give you all kinds of information in this, starting off with just an overview of what it is, what did we use, what did we scan, and most companies should be providing this kind of report. You know, if you have someone that's just got a camera in hand and they go, that's hot, that's hot, that's hot, deal with it. What? How would you trust that? You know, if they're not able to document it and articulate what the problems are and why and how to fix them, then how do you know that's even a hotspot to begin with? We'll get into that in a minute. Okay, so somebody who can document out and tell you exactly what they did and why is very important. So we include that in our reports. A nice summary telling you, you know, how many locations were scanned and how many have potential issues, I should say. And we categorize them kind of in 4 ways. So potential deficiency, you know, you got to monitor it. There's some potential, I would consider that condition 2 equipment at that point. The probable deficiency, you know, repair it as you have time, versus a critical deficiency, which means there's immediate action needed. Like, this is evidence of impending failure at this point, and you need to take action. Going back to risk assessments and knowing, you know, normal operating condition, if there's evidence of impending failure, such as we've marked it as a critical deficiency, that needs to be top priority. Okay, so makes it a nice little color code, red, yellow, green. If it doesn't have a color, no action required. We scanned it. There's no deviation in temperature that is to be concerned. It's well within the expected range for that piece of equipment. Okay. And then there's more information about the NEPA and 70B requirements as far as you know, what it says and why we've said there's a deficiency, you know, potential, probable, or critical. What deviations are we pulling from? All of that is documented and referenced for you so that you know, again, we're not just pulling this out of the air. This is based on engineering expertise. Okay, so there's the example of a thermography table. Lists out everything that was scanned, and it'll tell you the deficiency level, problem description, such as, is it a deviation between the phases, is the entire thing overheating, and off to the right, you'll notice there's a condition number. And wouldn't you know it, it aligns with what we were talking about earlier as far as the condition of the equipment for maintenance interval modifications as well. If there's a critical deficiency, that's obviously going to be condition 3. But you know, it's not causing problems currently, but you still need to monitor it, condition 2. And then condition 1 is the stuff that, well, there's no actionable item because it's operating as it should be. Okay, so let's look at a couple examples. This first one, it's not got anything marked. Deficiency level, and I'll zoom on this in a minute, there's nothing marked. But you look at this at a glance and you think, oh yeah, there's definitely a hotspot. Is there? Well, let's zoom in a little bit here. If you look at the temperatures, and I'm realizing now it's still a little small, but the temperature range on the left, the guide that tells you what the difference is in temperature for the color, it's 60.7 degrees to 68.4 degrees. We're talking 8 degrees difference. The coloring looks like there's a big hotspot there, but in reality, there's not. That is not enough of a deviation for us to really be concerned about it. Plus, it's under normal loads. So the cooler, the more purple parts aren't supposed to be warming up. But electricity, there's always going to be some heat expenditure as you're having a normal operating condition, even to this level, right? So the level of heating is not of concern. There's no recommendation needed. Again, you have to have somebody with a camera in hand that actually knows what they're looking at and all the parameters involved with a proper infrared scan, okay? Now, this next one, there is a potential deficiency. Kind of looks similar as far as the coloring range. But then you look on the left and you realize it's 70.4 degrees to 97.9, almost 98 degrees. That's a much bigger delta right there, okay? So it makes sense that just looking at the colors doesn't really tell you what you think you might need. So in this example, there's single pole breakers, and there's some that have higher heating than expected for the environment and the amount of load that we would anticipate. So a lot of times this is from loose connections. Okay, so we know that the load on here isn't overdrawing, but maybe something's loosened up or maybe it needs exercise. So we've given some comments and some examples, depending on the situation, of what to do to help correct this. All right, here's another one that's probable deficiency. Okay, so we see that one of the phases is quite a bit warmer than the other two. Okay, that's again another problem that we see quite often, typically associated with a loose connection, possibly some unbalanced loads, but I'm going to tell you right now, most of the time it's from a loose connection. At least that's what it feels like, if you just generalize this. Okay, and then a probable or critical deficiency would be things that, well, this is a wide range. We're looking at our range from 68 degrees basically to 187. That's the delta difference of the coloring that you see here. That's a critical deficiency. If the larger the delta, the higher the chance of a problem, okay? So we're almost up on time here, so I just want to throw out that yes, we can do infrared scanning. We can look at your equipment, provide you a preventative approach for avoiding these equipment failures, which help avoid arc flash and shock events and electrical fires and unexpected downtime. There's too many reasons that are positive to do it that it's kind of a no-brainer. So making sure that you have that completed is very important. Whether we do it or whether you get a camera for yourself, that's fine. Just again, make sure it's someone who knows what they're doing so that you get the most out of it. Okay, if you have any questions or if you would like assistance or more information on this, please don't hesitate to reach out. Our website and phone number are right there. You can email me directly. That's my email right there on the screen. Otherwise, with the last couple minutes, I'm going to open it up for any questions that might be present today. Appreciate you all attending. If you want to reach out, please don't hesitate. Otherwise, I am opening it up for questions right now. Thank you, guys. It looks like I did get a couple questions, but I answered them as far as, what would be a typical cause of overheating, loose connections, unbalanced loads, that kind of thing. Overloads can do it too. You would hope that your protective device would operate if there was too much of an overload, but it's possible. Got another question here. Are there IR cameras that allow the person scanning to stay outside of the arc flash boundary? I want to say yes. I would say the majority of, well, not the majority of, there are definitely cameras that are a high enough image capability that you can stand back further and even zoom in a little bit so that you can stay outside the arc flash boundary. Just two things there. First of all, you have to know what the boundary is. It's very dependent on that system and on that equipment. So you have to have the study done to figure out, well, what even is the boundary. If you have that, great, I'll move on. Second thing, who's opening the equipment? So if you have someone who's qualified that can open the equipment, and then the person that knows the camera can stand outside the boundary and get the scan from back there, great, but now you have two people that you need for every scan. Otherwise, the person doing the scan has to suit up to cross that boundary. But yes, they do make cameras that can go out far enough, as long as you have all those other parameters fixed first. What's your opinion of equipment being installed with IR scanning windows? Love them. Absolutely love them. Because then that way you don't have to worry about opening it up for every scan either. Now, there could still be sometimes, depending on where the infrared window is installed, that you can't quite get a clear view and you are suspecting that there's a problem, yeah, you still got to open up the equipment, but it takes out so much of the time just to open things up, and it lessens your exposure, because if you can keep it closed and do your annual or 6-month scan and just move right along, the time, the lower risk, love them. They're absolutely phenomenal. The problem is a lot of people don't have them yet, and so you're looking at retrofitting or installing a new cover, that kind of thing. But if you have the ability to invest in that, I say go for it. Rated ones, specifically, I want to be clear. Reputable suppliers, rated ones, don't jimmy rig your own, okay? Because then the exposure thing is still a problem. All right, I'm gonna keep it open for a few more minutes. Otherwise, you guys just seriously feel free to send me an email. I'll follow up with you as best I can. And even if I don't know the answer, we have plenty of people who could talk to you in more detail about stuff. I know quite a bit, but I'm not, an expert in absolutely everything, right? So we have a wide group of talented individuals who can really dive into the specific subjects as needed. Otherwise, I will fade into the background a little bit. Thank you so much for your time, guys. I really appreciate it. And I'll see you on the next one, hopefully.